So we are taking a reagent of Fe1 plus, okay, small amount, and then I am adding some magnesium. Just look. So nothing happens, so no change. So no change, then no change. So this is not an alcohol, this is not an acid. Fb2 class, the candidate wrote that effervescence occur, but it should not be any effervescence. Maybe the candidate's test tube was not cleaned properly, or he didn't clean it properly. But Fb2 class should not give any change with sodium carbonate or magnesium, because Fb2 class reagents, they were actually aldehydes and alcohol containing reagents. So it should not give any effervescence with sodium carbonate at least. When bromophenol blue is added, so no change, but yellow solution formed. So Fb3 class is an acid, carboxylic acid. And when heating with 2,4-DNPH with Fb2 class, there must be a yellow precipitate, but the candidate has got some wrong interpretation. Here no gas should be formed, here no gas should be formed, and here no gas should be, no visible change should have been occurred. So maybe the test tubes were not cleaned properly. And lighted splint pops, that means the candidate interpreted that it was hydrogen gas, but we didn't add any metal over here, isn't it? Hydrogen gases evolve when metal is added with acid, but 2,4-DNPH is not a metal, so it should not give any pops on with lighted splint. Maybe the candidate has got some wrong interpretation. So this should give some change, but since it didn't give any change, so it's no change. All right, it should also be a no change, and here a gas will be evolved. A metal is added, a gas is evolved. So here the gas is hydrogen, and it should have turned, it should have given a pop sound with a lighted splint. Sodium carbonate effervescence occurs since carbonate is present, so gas is produced over here. This is wrong, gas is produced over here, so this gas must be carbon dioxide, and he should have written that lime water turns milky. And 2,4-DNPH, it should give a yellow or orange precipitate over here. So a carbonyl group is present in Fb2 class. Now when failing solution is added, so yellow solution formed with failing solution. So yellow, red, green, they all means that with failing solution, they all actually means that aldehyde is present. Like if there is a change with failing solution, yellow, green, red, brown, so that means aldehyde is present. So a small amount of PCl5 is added, white fumes produced, so it must contain an OH group since PCl5 is present. Now we are adding bromophenol blue, so no change, that means no carboxylic acid group is present over here, okay, but he has written carboxylic acid, so it must not be correct. So the functional groups are aldehydes because failing solution gave a change, and an alcohol because with PCl5 there is a change. Now later, when you have added progesterone, so with aqueous iodine, yellow solution formed. With clear sodium hydroxide, solution turns clear, but with aqueous iodine we have got yellow solution. So this must contain the CH3CO group, that means the methyl ketone group, the iodoform test. But when PCl5 is added, he said white fumes formed, but the test tubes were not clear, I think, so he has got some wrong interpretations. So PCl5 should not give any change here, or maybe water is present. So the conclusion that can be drawn from the test, that a yellow solution, yellow precipitate, so test tubes were not clear properly, so it will be yellow precipitate or yellow precipitate here, solution here, and PCl5 no change. So the progesterone does not contain any hydroxide group, but instead it contains the CH3CO group, as it said. With CH3CO group, due to presence of CH3CO group, there is a change, and OH group is present, so there is OH group is not present. So with PCl5 there must be no change. This has to be written over here. All right. Okay. So that's all for the solving of mock paper of identification of ions. Thank you.